Hello friends, welcome back to Edupedia world. The previous lectures we saw the details about refraction through a glass slab. Today we'll be visiting a new uh, term called prism. We'll understand what a prism is and we'll see what angle of deviation is in a prism. Also we'll find out the important relation between the angle of deviation, the angle of a prism, the incident angle and the emergent angle. So let us see this in details. Today's lecture we will focus on refraction through a prism. To begin with, we need to understand what a prism is. Only then can we dive deep into refraction through a prism. So what a prism is that it is basically a transparent medium bounded by 5 different planes. This is an example of a prism. Here we have one triangle here, one triangle which is parallel to this at the back, and 3 rectangular surfaces, one here, one at the bottom and one on this side. This optically different medium, this confined space, is called as a prism. Now this surface, let's call it as ABC. This ABC is called the principal section of the prism. So this triangle is the principal section. This angle ABC opposite to the base is called the angle of the prism. So this angle B is the angle of the prism. Now these rectangular surfaces, this rectangular surface and the one over here would be called as the refracting surface, and this edge which joins the two refracting surfaces is called the refracting edge. So let me write it down. This is the refracting surface, and basically this edge is called the refracting edge. This we call as the angle of prism. So this is, we have seen to be the angle of prism. These are some of the important technical terms that we use while discussing prism, so it's good that you know them beforehand. Now the next step is to see how the refraction actually takes place through a prism. So to understand that, you have to figure the front surface, the principal plane, that is A, B, C. Now if we draw the surface here, ABC, let's do one thing. Let's call this as B, this as A, and this as C, such that BAC is the angle of prism. Okay, now that implies that BAC, so this is the principal plane, this is our base of the prism, and this is angle of the prism. Now a ray of light will come and strike one of the refracting surface. Let's say that light is traveling in this direction, then the ray of light comes and strikes here. Fine. Now if we draw the normal, let me draw the normal. If this is my normal, then this is the angle of incidence. Let me write it as I, right? And we know that this surrounding the prism is air. The prism is an optically denser medium. Normally it is made out of glass. So this is light traveling from a rarer medium to a denser medium. As a result, the ray of light will bend towards the normal, something like this. Let's call this as R1. And again the ray strikes here. If we draw the normal, and let's call this as R2. So what is happening is that the ray is impacting the first surface AB at an angle of incidence I. It's getting refracted with the angle of incidence, angle of refraction R1, and it is impacting the second surface at an angle of incidence R2. Now, since the ray is traveling from a denser medium to a rarer medium now, the ray of light will bend away from the normal. That would be something like this. And this angle will be the angle of emergence. Let's call it E. Okay. Now, what we see here is that there is deviation of the ray of light being caused at both the planes, the plane AB and the plane AC. So there will be a net divergence from the actual path, from the initial path. So how much will that divergence be? Let's draw it. Let's suppose that the ray of light did not encounter the prism. Then it would have followed the straight line. Okay. But since the ray of light did encounter the prism, there has been a change of path. By how much did the path change? Ultimately, the net change in path is, let's use red, is this whole angle. And this angle is represented by delta. This is angle of deviation. Angle of deviation. Right? So some of the deviation is caused at the first surface, rest is caused at the second surface. But net total deviation is delta. Now we need to find the relation between delta and the angle of incidence and the angle of the prism. How can we do that? In order to understand that, we need to find what delta is composed of. Delta is basically composed of the deviation here and the deviation here. Let us segregate the two deviations. Let's call this deviation over here as delta 1, and if we extrapolate this line, then this is the second deviation, delta 2, which is same as this delta 2, right? So this is delta 1 and this is delta 2. I'm not writing it down there because of lack of space. Now if we consider what delta 1 is, we can find it out. Let's see what delta 1 is. Delta 1 is equal to, if you note carefully, this is I, angle of incidence, this is I, right? Because these are like the opposite angles. So I and I, this is delta 1, therefore delta 1 can be said to be I minus R1. Okay, I minus R1. Similarly, delta 2 can be said to be E minus R2. These two equations, and knowing that delta is equal to delta 1 plus delta 2, we can say that delta is equal to I plus E minus R1 plus R2. Now we have a relation of delta in terms of angle of incidence, angle of emergence, and the R1 and R2, which are the refracting angles. We need to find a relation of R1, R2 with angle of incidence. Let's do that. Let us consider quadrilateral APQR. We are looking at this APQR. In this, we know that this is the normal, so the angle APQ is 90 degree and ARQ is also 90 degree. Let me write it down. APQ is equal to ARQ is equal to 90 degree. And we know that the sum of the angles of a quadrilateral will be 360 degree. Therefore, what we can say is APQ plus ARQ plus PQR, this angle, plus let me call it this A, plus A is equal to 360 degree. Replacing these two, 90 and 90, we get PQR plus the angle of the prism is 90 plus 90, 180. We take it this side, so this is 180 degrees. So what we get is that PQR and PAR sum up to 180 degrees. Now if we look closely at the triangle PRQ, what will be the sum of the angles of the triangle? The sum of the angles of the triangle will be 180 degree. Therefore, what we can say is in triangle PRQ, R1 plus R2 plus PQR is 180 degrees, right? This angle plus this angle plus this angle is 180 degrees. Let's call this as equation number 1. Let's call this as equation number 2. This as 3. Now we can replace PQR to equation 2. If we do so, we have to replace PQR as 180 minus R1 minus R2. We do that, replacing 3 in 2. That will give us, replacing the PQR from 3 in 2 will give us 180 degree minus R1 minus R2 plus A is equal to 180 degree. This will imply A is R1 plus R2. Let's call it equation number 4. When we replace this equation 4 in equation 1, what we get ultimately is this very simple looking equation. Delta is I plus E minus A. If we take it over there, we get angle of prism plus angle of deviation is angle of incidence plus angle of emergence. This is a very important equation. Now this, what does this say? This says that the angle of incidence and the angle of emergence will sum up to the angle of the prism and the angle of deviation caused by the prism. In the next lecture, we will see some of the important factors which affect the angle of deviation we mentioned here. and we'll also see a numerical to see how the angle of deviation can be calculated. Today's lecture we understood what the prism is, what are the different terminologies associated with the prism, and then we calculated the very important relation of relation between angle of prism and angle of deviation with the incident and the emergent angles.